problem of doing a percent yield stoichiometry type problem. We're going to go from mass to mass, and let's go ahead and get started. The question's asking, if 10.5 grams of aluminum react with excess oxygen to produce 15.2 grams of aluminum oxide, what is the percent yield? One of the problems with this to get started is you now have two values to start from, and you don't necessarily know which one to go with. Here's what I would recommend when it comes to percent yield problems. You are given a reactant at 10.5 grams of aluminum. So notice that it's a reactant. And you have 15.2 grams of aluminum oxide, which is here. My recommendation is to start with the reactant itself rather than the product, because this is the amount that got made, but we're not sure whether or not that's 100% of what should have been made. So we are going to use the 10.5 grams of aluminum, figure out how much aluminum oxide was made, and then compare it to what was experimentally collected. So to get started, we're going to have 10.5 grams of aluminum over 1. Then we're going to need to be able to convert this completely into grams of aluminum oxide, just like a standard mass-to-mass stoichiometry-based problem. So to do that, to convert from the grams into moles so we can use the balanced equation, I'm going to put the molar mass of aluminum, and it's 26.98 grams of aluminum. Then we're going to need to put in the mole-to-mole relationship. In order to have the mole-to-mole relationship, we would need the equation balanced. So make sure you know how to balance the equation itself. Molar mass for the balanced equation will be 4, 3, and 2. So from here, I know I want to get rid of moles of aluminum, and I want moles of aluminum oxide. I have 4 moles of aluminum in the balanced equation and 2 moles of aluminum oxide in the balanced equation. So now the moles of aluminum cancel, the grams of aluminum cancel, and right now I have moles of aluminum oxide. Now I still need to get it into grams of aluminum oxide so I can compare them. The molar mass is what we'll need of aluminum oxide. The molar mass for aluminum oxide is 101.96 grams of Al2O3 for every 1 mole of Al2O3. Moles of Al2O3 cancel with the moles of Al2O3. The molar mass of the aluminum oxide you can calculate by adding up 2 aluminums with 3 oxygens to get the total of 101.96 grams. So now at this point, it's a matter of using your calculator to figure out how much aluminum oxide should have been made. So you would take the 10.5, you would divide that by 26.98, 10.5 divided by 26.98, divided by 4 times 2 times 101.96 gives me 19.8 grams of Al2O3 that should have been produced. So this is the should have. So this is what we should have had. The 10.2 grams is what we actually produced. So to figure out the percentage, we're going to take the 15.2 grams that we did in the experiment divided by the 19.8 grams of the Al2O3 that was produced to get a total of 76.6%.